In this video, we're going to continue our work with the normal distribution curve and z-scores. So we're going to look at some examples where z-scores aren't going to work out perfectly. So what that means is instead of being able to draw out your normal curve and see that your values are between 1 and 3 standard deviations of the mean, we might have things like 1.25 and 2.75 as our z-score. So let's go into this example so you can kind of see how that all plays out. So the statistics for the math portion of the SAT had a mean score of 480 and a standard deviation of 24. Assume the scores are normally distributed. What is the probability to the nearest 10,000th that a test paper selected at random scored between a 510 and a 540 on the math section? So let's go ahead and start with our picture. So let's draw out our normal curve here. And let's go ahead and label what we have. So we have the mean is 480. And standard deviation of 24. So let's start with the right-hand side here. So add my 24. So I have 504. Add another 24, so 528. Add another 24, 552. So when we look, we're trying to identify, so I'm not going to bother with the left-hand side here because I'm only really focusing on positive values. You don't always have to label your normal curves completely, just so you know. We know that there would be values over here, but I don't really care about them for the sake of this problem. So I'm not going to worry about those. But what I do know is that when I look at my picture here, 510 and 540 do not perfectly fall on one of these pre-labeled points or one of these one of the whole number standard deviations away from the mean. So if I look, 510 would be somewhere in here. So let's say about here would be 510. And 540 is going to be somewhere in here. So this is the section that I'm looking for. But the problem is I can't use my calculator and do the normal CDF because I don't know what these z-scores are. So what I need to do is I need to find the z-scores first. So my step one here is going to be to find the z-scores. Because I can't just say, oh, it's one standard deviation above the mean, therefore a z-score of 1. I don't know that. It's somewhere within 1 and 2 standard deviations. This value is somewhere between 2 and 3 standard deviations. So what we're going to do is we're going to use our z-score formula. So for the first one, I have z equals, so x, remember, is the individual data point. So if I say 510, that's going to be my x value. That's my individual data point. So 510 minus the average, so the mean is 480, divided by the standard deviation. So we just type that in into our calculator. I get 1.25. So this has a z-score of 1.25, which makes sense because it's a little bit above 1 standard deviation above the mean. And then for the 540, I can't even read what I have here. So for 540, we'll plug in 540, subtract off the 480, divided by the standard deviation. So that's going to give me 2.5, which again, that makes perfect sense because that's about halfway between the 528 and the 552. So this is a z-score of 2.5. So 2.5 standard deviations above the mean. So now that I know my z-scores, well, now I can go ahead and calculate the probability of being between 1.25 and 2.5. So we're looking at from 1.25 to 2.5. That's the probability. So those are our z-scores. So I'm going to do the normal CDF of 1.25 to 2.5. And again, we'll keep the 0 and the 1 the same. And then we're going to just type that into our calculator. Let me show you again just as a reminder. So it'll be menu, statistics, distribution, and then number 2 for normal CDF. We'll type in our 1.25 to 2.5 and then just say okay. And we get our value here. So let me record that. So I end up with 0.09944. We're rounding this to the nearest 10,000th. So 4 decimals. So 0.0994 is our probability for this. So that's the likelihood of being between 510 and 540. So let's try another example. So it's very much the same as what we saw in the last section. It's just now we have z-scores that we have to do a little bit, we have to do the calculation for. So the distribution of a monthly rent for 1-bedroom apartments in a city is approximately normal with a mean of $936 and a standard deviation of $61. A graduate student is looking for a 1-bedroom apartment and wants to pay no more than $800. So no more than that. Of the following, which is the best estimate of the percent, so we're looking for a percentage, of 1-bedroom apartments in the city with a monthly rent of at most $800. So we're looking at less than or equal to 800 is what we're looking for. So we want to know what is the probability that you can find an apartment that is less than or equal to 800. So let's go ahead and draw out our picture. So we have our normal curve. Our mean is $936. Standard deviation is 61. I want to get to 800 if possible, so I'm going to just label the left-hand side here because I want to go smaller. So I'm going to subtract off 61. So I get 875. Subtract off 61 again, you get 814. Subtract off 61 again, and we get 753. So unfortunately, when you do this, you realize, okay, the 800 isn't one of these integer values for z-score. So I know that the 800 is going to be somewhere in here, probably a little bit closer to the 814. So somewhere in here, I want to know what's the probability of being less than or equal to 800. So I want to know what's the probability of this orange region. So the first thing I need to do is find the z-score, because I don't know how many standard deviations is 800 below the mean. I don't know. I know that it's going to be somewhere between -2 and -3 standard deviations below, but that's about it. So for the z-score, I'm going to say z equals, so it's going to be 800, the data point, minus the mean, 936, divided by the standard deviation. So I type that into my calculator, and I get a fraction. I'm going to actually record the fraction because then I can type that in. But I end up with, this approximates to -2.22951, which again makes perfect sense because I said it's between a z-score of -2 and -3. So -2.2 makes perfect sense for this. But what I'm going to do in my calculator is I'm actually going to use the fraction when I type in. So for the second part here, we're going to do our normal CDF, and I'm looking at, so it's going to be negative infinity to the -136 over 61, or to the -2.22951. So I'm going to type in -99 to the fraction here because I want to be exact. And then I'm going to keep my 0 and 1. And I'm going to let you go ahead and type that in and confirm that we agree. I got 0.01289. We want to find the percent of people. So this is the probability of being $800 or less. The percent, not percent of people, but the percent of 1-bedroom apartments would be times that probability by 100. So we end up with 1.289%. So 1.289% of apartments are going to be $800 or less a month. not very likely that they're going to find this person searching is going to find a one-bedroom apartment that's $800 or less, because only 1.28% of them are $800 or less. So it's really, we're looking at 1.3, so it'd be choice A, 1.3% of apartments. So let's go to the next page, just try a couple more examples. So for number 3, the scores on a standardized exam have a mean of 82 and a standard deviation of 3.6. Assuming a normal distribution, a student's score of 86 would rank. So notice that all of these problems always talk about the normal distribution. That has to happen for us to keep drawing this normal curve and using it. So they should all say that in the problem. So just, you're going to see it in the problems, but just so you know that it does need to be there. So my score of 82 and standard deviation of 3.6, we're trying to get to 86. So again, I'm only going to label the right-hand side here. So I'm going to add 3.6. So I have 85.6. Add 3.6 again. We have 89.2. And now I've passed really where that 86 is going to go. So I don't even really care about that third value. But what I do care about is this 86. So 86 is going to be pretty much fairly close to this 85.6. So here's my 86. And we're trying to figure out their percentile rank. So remember, percentile means you need to know what percentage of people did you score better than. So that means you're looking at this region in here. This is the percentage of people that you scored higher than. So what we need to do is we need to find the z-score associated with 86. So let's go ahead and do that first. So the z-score, so z equals, so 86 minus the mean, 82, over the standard deviation, 3.6. I get 10 over 9, which I'm going to leave as 10 over 9 because I want to keep this as accurate as possible. And now when I go to do the normal CDF, I'm looking at from negative 99 because I want this whole region in orange. That's the percentage of people that we scored higher than. So negative 99 to the 10 over 9, and then keeping the 0, 1. Go ahead and type that in, and I get 0.8667. Times that by 100 to get the percent. So we're looking at 86.67%. So a score of 86, now it's just a coincidence that it happens to be 86 and 86%, but a student score of 86 means that you scored higher than 86.67% of people. So that means your rank would be between 85 and 95 if we look at our choices here. So that's the percentile rank. And we'll keep moving here. So number 4, on the Algebra 2 trigonometry midterm at Champion High School, the scores of 210 students were normally distributed with a mean of 82 and a standard deviation of 4.2. I feel like we've seen this scenario in the last section, but now what we're trying to do is we're trying to determine how many students scored between 79.9 and 88.3. So I believe we set this up in the last section, but the difference is we're going to see that these scores do not fall on integer values for z-scores. So let's go ahead and draw our picture. So we have our normal curve, our average is 82, our standard deviation is 4.2. So we're looking at 79.9 and 88.3. So I'm going to go until I get those scores. So 82 plus the 4.2 gives me 86.2. And then I'm going to have to add another 4.2 to that, and I get 90.4. And I don't really care about that last value because I know that 88.3 is going to be somewhere in here. The 79.9, I need to go below the mean. So let's go below 1 standard deviation. We get 77.8. And again, there would be two more below, but I don't really care about those because I care about between 79.9 and 88.3. So 79.9, somewhere in here, and 88.3 is going to be somewhere in here. So we're looking at this region. We're trying to figure out how many students scored in that region. So notice again how many students. It's not asking for a percent, it's not asking for a probability. So what I need to do is I need to figure out, well, what is the percentage of students that scored in this region so that I can then take it out of the 210. So the percentage out of the 210 students. So let's go ahead. First thing we got to do is we have to find those z-scores. So that's going to be our first step here, since I don't know the z-scores. So my first one here, I'll do the 79.9. So z equals, so 79.9 minus the average, 82, over the standard deviation, 4.2. So this gives me negative 0.5. So that means it's exactly halfway between a z-score of 0 and negative 1, which makes perfect sense. So this is z equals negative 0.5. And then for the 88, so 88.3 minus 82 over 4.2. This gives me a z-score of 1.5, which again makes perfect sense, exactly halfway between z equals 1 and 2. So now I'm going to do the normal CDF to figure out the percentage. So normal CDF between negative 0.5 and 1.5, again keeping the 0 and the 1. You'll type that into your calculator, and I got 0.624655. That's the probability of being in that region. I want to know how many students, so the number of students will be basically 62% of the 210. So I'm going to take the 0.624655 of the 210, so multiply those, and we get 131.178 students. Can't have 0.178 of a student, so we only have 131 students that satisfy the condition here. So 131 students out of the 210 have scores between 79.9 and 88.3. They fall in that percentage or in that region. And the last question here is a little bit different. So let's just read through this one. So the distribution of the diameters of a particular variety of oranges is approximately normal with a standard deviation of 0.3 inches. How does the diameter of an orange with a standardized test score of 0.44 compare with the mean diameter? So a standardized test score of 0.44 really means that the z-score is 0.44. So what this means is this is 0.44 of a standard deviation above the mean, right? Since it's positive, it's a positive value. That means it's above the mean, it's to the right of the mean, and it's not quite a full standard deviation above the mean because a full standard deviation would be 0.3 inches. This is only 0.44 of that full standard deviation. So really what I need to do is I just need to figure out 0.44 or 44% of this 0.3 inches of this full standard deviation. So all I'm going to do is do 0.44 of the 0.3 inches from the mean. So basically 0.44 times that 0.3 inches, because that 0.3 inches represents one full standard deviation. Multiply those together, and I get 0.132 inches, and this is going to be above the mean because it's positive. So that's the shortest way of doing this. So there's my answer. 0.132 above the mean. You could also use the formula. I just want to show you that. So what you can do is you could take your z-score formula. So z equals x minus mu over sigma. Plug in what you know, because this one's interesting because you didn't know the mean this time. So we have the z-score is 0.44. I don't know the individual data point, so that's x. I don't know the mean, so leaving that, but I do know my standard deviation is 0.3. And then if you go to solve this mathematically, well, put that over 1, cross multiply, we end up with x minus mu is equal to 0.44 times 0.3. So that's going to be the same thing as 0.132. And it's asking you, how does the diameter of this orange compare to the mean? So basically solve for the data point. So of this particular orange with this z-score, so bring this, so we get x equals, so bring the mu over, it would be 0.132 plus the average. So basically what this is saying is it's 0.132 above the mean, is this one orange that has this standardized score of 0.44. So that's how you would use the formula to interpret this. But you could also just do it by kind of thinking about, okay, it's 0.44 of that one standard deviation, which equals 0.3. So that's why you multiplied the two. So that's it for this video with z-scores. So basically, if you combine the last section and this section, it really should give you a good understanding of the purpose of z-scores and how we can use those to interpret. So from here, go ahead and do the homework problems.